Okay, I guess this is not powered by Zenoh here, so therefore we have the black screen right now. But I'm sure we will have, the presentation. Oh, this is a quiz. So, question to Fanny so far. What is the name of the dragon?
So we released 1.0. I want to make an announcement. 1.0 is called a fire song. So it's a dragon fire song. Yeah. Since I announced it that we have a release, question?
The sound. Yeah.
Hello?
Yeah, no.
Check. So just before OCX and Roscoe, we released Zenoh 1.0. So it's a great achievement. So I want to congratulate the entire Zenoh R&D team for this amazing work. It took it was a lot of effort to put it out there. We wanted to release in April, but a lot of things came in the way, so we had to release. We have to postpone it, but we managed to release just before OCX. So huge shout out to them. So my name is Fanny Gangula, Senior Solutions Architect at Zetta Scale. At Zetta Scale, open source is the foundation of everything we do. Yeah? We have two great projects, Eclipse Zenoh and ZenOflow, which are part of the Eclipse SDV ecosystem. And we are based out of Paris. Part of our development team is based in Netherlands, and we have our customer support team in United Kingdom. So there's supposed to be another speaker today, my colleague Gabriele Baldoni, who is the principal engineer of Zetta Platform. Now he has to integrate the latest version of Zenoh into the Zetta Platform to bring the new features to the users and the customers. So he couldn't able to join, so huge shout out to him as well. So today's topic is how we are redefining automotive connectivity with the Eclipse Zenoh and the Zetta Platform. I don't know how many of you in the audience already familiar with Eclipse Zenoh. Okay, that's a good number. Glad to hear. So for people who are not familiar with Eclipse Zenoh is a communication protocol, and Zetta Platform is a platform that leverages Zenoh to provide a first ever platform as a service using Eclipse Technologies. Yeah. So let's dive in. A couple of months ago, we did a demo. Not just a demo, we did a webinar, and right after the webinar, we jumped onto the car and started streaming the video data to a Zenoh router, which is sitting in the Frankfurt, deployed through our Zetta platform, sitting on the AWS cloud. And this Zenoh router in the Frankfurt, streaming the data back to our offices in France, where there is an AI engine, basically picking the data, classifying the images, and as you can see, it's detecting the objects over there, and sent back to the laptop over here, which is being displayed again. So all of it is done using Zenoh on a basic mobile network. So there isn't any special industrial network that has been used to stream this data. And this is something most of the protocols out there not unable to manage. By the way, on your right side, that's Gabriela, and the one who is driving the car is our CEO, CTO, Angelo Corsaro. So before I explain what Zenoh and Zetta Platform is, I want to run into the challenges, what the industry is facing. By the way, it's a complementary to what Stephen and Kai have just presented. It was a music to ears, to be honest. These are something, basically I'm preaching to the choir. You already know the challenges, but we see very few solutions, but there are a number of challenges in automotive industry. Of course, as Kai explained, we have frameworks out there which are dealing with the traditional architectures, and these are not well equipped for the modern software-defined vehicles, where we are not satisfying the engineers. They're not able to use the latest CI/CD pipelines or DevOps infrastructure. And basically, what they're doing is dealing with the configuration of the application rather than developing it. So your differentiator is the application, but you're configuring instead of developing something. So that keeps the motivation of the engineers also very low. On the other hand, customers are expecting features where they're expecting you to update the software over the air. So there are challenges on both sides, but the architectures what we have today are unable to tackle them. And the second point being the connected car aspect. By 2030, 80% of cars are going to be connected. And current infrastructures, be it if you want to do platooning or if you want to communicate to the edge infrastructure and to the cloud infrastructure, is not yet there. And the protocols today impose a certain architecture on you, like you have to do the client broker architecture. Imagine if you have a fleet of vehicles sitting in a given city, and there's a sudden disconnect and reconnect, there's a huge storm of TLS traffic coming out of this area. And this is basically a zero-day attack, right? So the current protocols and infrastructure also fall short. And by the way, there's a good news out of this. We are not alone. It's a cross-industry problem. So it's a problem in robotics as well. These guys are pretty fast. They are adapting to the new technologies, new communication technologies. They also have to do the swarm computing. They have to teleoperate the robot, right? And of course, it is also high-volume data, just like autonomous car. And similar story with the IoT, where you have to do the processing at the edge. Something has to be sent to the cloud. And also the same issue with the aerospace industry, where everyone is patching the multiple technologies to make the data flow from the device to the cloud, from the thing to the cloud. So what we end up is basically with a digital Frankenstein. Yeah? The people who are benefiting out of such Frankenstein are basically the system integrators. Not your customers, not your engineers, the system integrators. They are making good money, of course, yeah, because you have to maintain them by integrating multiple things. And when I'm talking about just making the data flow from one point to another point, yeah, there's this other set of technologies that are used to tackle the databases, another set of technologies to tackle the computations. And we just did not come to the problem like, yeah, that's something we have to do, but we had a technology in the past where it's being used in smart cities and other key infrastructures, and we were hitting these walls where we are doing the workarounds, a kind of a gateway here, kind of a gateway there, so it was a huge mess. And then at some point we decided, okay, enough is enough. Someone has to solve this problem. So that's exactly 5 years ago, we started a ground-up development of a new protocol, which is Zenoh. Yeah? With Zenoh, we want to tackle simple problem. Actually, when you explain the problem simple, you could be able to solve it. So the idea is to unite the data in motion, data at rest, and computation from the smallest microcontroller up to the cloud. And we do that with just 3 simple mechanisms: pub, sub, and query. And pub sub is for the high-speed communication, which is between sensors and actuators. And query is to query the data from a database or a queryable, or a computation, where a live, fresh data is computed and sent back to you. And Zenoh does it in a location-transparent way. That means you don't have to know where your queryable is. All you have to do is to pass the query, and Zenoh figures that out for you and gets the data from the data storage, if it is available in the data storage, or if it is a queryable, it hits the queryable and gets back the data for you. So since we built such a great communication layer, we had an ability to provide a framework on top of it, which is a data flow programming framework, which is another Eclipse project, which is called Zenoh Flow. Zenoh Flow basically helps you to configure your data processing applications into small nodes and have execution control on it. So if you're looking into data processing application, that would be a right project to look into. Another aspect is, since we're getting a traction in automotive, we started working on ASIL-D certification. So if there's an interest around ASIL-D protocols, communication stack, so feel free to reach out after the presentation. And the beauty of Zenoh is its code is completely written in Rust. Yeah? So as you can see, you don't have to be Rustacean. We can also provide APIs in several different languages, from C++ to Kotlin. Even Kotlin can be used for your Android applications. We chose Rust because we develop mission-critical, real-time critical systems, distributed systems, and these require memory safety, concurrency safety, and high performance. These are the guarantees what Rust provides. And back then, it was a wise choice to go with Rust, where not many engineers were working on it back then, but we still went with our gut feeling, but it turned out to be a great choice today. And in Zenoh, we have a built-in shared memory option. So with a zero copy. The built-in shared memory support has been reworked in 1.0. It has now got the new features that are quite customized for the automotive use cases and also for the robotics. And the beauty of this shared memory is it doesn't need a daemon. Yeah? Normally, if you have a shared memory daemon, when you have multiple applications on it, and if you want to add a few more applications to your shared memory, you have to restart the daemon, right? So that doesn't work in current architecture. You have to be more flexible. So with Zenoh shared memory, you don't have a daemon in place. It's completely decentralized and very well optimized for the Zenoh's architecture or topological architecture. I'll come to the topology aspects very soon. And then, as you can see, it can scale from data link layer up to the transport layer. So that's the reason why we say it can scale from smallest thing to the cloud. So that means you don't have to use the TCP, UDP, or QUIC, any other top-layer protocols. You can also use the low-level transport layers like Bluetooth, serial, anything you can imagine. And we have a subset of Zenoh completely written in C for embedded devices. So that you can run it on microcontrollers. And as you can see, the overhead is as low as 5 bytes. That means if you're running Zenoh on constrained networks or embedded devices you work over, even the small, tiny devices can support Zenoh. And it can run everywhere. We recently also ported Zenoh to QNX. We have an implementation. We have a porting for that as well. It supports various targets, including the classic AutoSAR framework as well. So if at all, we know that legacy will be there, so we have to support the legacy. So we started integrating into the AutoSAR frameworks as well. Now coming to the topology of Zenoh, Zenoh can do peer-to-peer communication in click and in mesh. In mesh, you can imagine platooning, swarm computing, swarm communication. And it can also do the routered communication, where clients can connect to a router, like a brokered communication. If it is a less resourceful device, it can connect to a router and participate in the rest of the system. Or if you need an arbiter somewhere in between, then you can also use such architecture to use a broker and a client kind of architecture. And you can also span these Zenoh routers. But Zenoh router is not a hardware, it's a soft router. You can place it anywhere you can imagine, like a MQTT broker. And you can span across your wide area network and connect to your Zenoh applications and have them communicate with each other. So if you take the comparison of the mainstream protocols out there, Zenoh is a different beast in itself. Yeah? If you see onto your left, the DDS, it can only do peer-to-peer communication. On your right, you have MQTT, it can only do the client-to-broker communication. And whereas Zenoh, it is a mix of everything. So you can have an end-to-end data communication with one single protocol. And Zenoh routers have an additional capability where you can load the plugins. So you can imagine a Zenoh router sitting on the edge infrastructure, having plugins to, for instance, to other protocols. It can communicate with MQTT or DDS, as a matter of fact, with ROS ecosystem as well. On the left-hand side, you can also have Zenoh routers hooked up to a storage. They can store the data. And when multiple Zenoh routers are storing the data of same data, they synchronize in the background. So you have a redundancy of your data everywhere. And whenever you do a query, it gets to the nearest storage, which is sitting close to you, and gets the data for you. And this is a performance. Performance is another aspect when we mainly compare throughput and latency. When you compare Zenoh with DDS, the throughput is three times faster than DDS, 23 times faster than DDS. With MQTT, if you see at 64 kilobytes, it goes really down. Yeah? And the latencies we hit as low as 10 microseconds, and we also have ultra-low latency support where we reach up to 6 microseconds. So that's a very impressive performance, what you get from Zenoh. Well, we are in the open source community. We have to talk about the open source frameworks and mention some of the adoption of Zenoh in such frameworks. The first thing comes to my brain without any exception is the work what Stephen and the team are doing. They're doing a very fantastic job. Shout out to them. They put a very cool framework that can unify your services from the vehicle to the cloud or to your mobile app. Speak different protocols can talk to each other without any issues using a single framework. And that is very let's say, tailored to the software-defined vehicle requirements. So please feel free to look out to that. So if you take a look at the uProtocol topology, what they realize is to do the in-vehicle communication within the vehicle, between the high computes, using Zenoh. The green lines are basically the inter-host communication between the Zenoh, and if you see within the device, the black lines, they are the shared memory communication, which I talked about, and the circle in the device, which is basically the Zenoh router, uses the plug-in mechanism to talk to some IP devices. So you can also talk to the legacy devices with the help of Zenoh plug-in mechanism. So it's a mix of some IP and Zenoh in a modern vehicle architecture. Of course, you can realize things without some IP, but we know that legacy will be there. We have to support the legacy as well. Another famous framework is ROS2. ROS2 stands for Robotic Operating System. And this is also popularly used in AutoWare. AutoWare basically takes the ROS2 stack and kind of optimizes this for the autonomous driving. It's also a nice community. So what basically ROS2 has a middleware layer, which is basically a transport layer. Previously, even today, they are using DDS. DDS stands for Data Distribution Service. So while they were using DDS, they ran into several issues. One of them being when they're scaling up, the robots getting overwhelmed with the amount of data that is being exchanged as we scale up, because there is a discovery traffic which goes around in DDS, which can be a bottleneck for the system, or when they take into the Wi-Fi, it doesn't scale well, or they want to put the DDS onto the small microcontroller, it doesn't scale well, because you need a minimum of 2 megabytes of footprint for DDS to run on a microcontroller. So all of these issues led them to think for an alternate option. Yeah, then they started looking into many middlewares out there and started an evaluation comparing all the middlewares. And this is an independent evaluation from the Open Robotics themselves. And they come to the conclusion that Zenoh solves most of the problems what they have in ROS2 community. So, yeah, and then we started working, and they selected Zenoh as the alternate middleware that they want to offer to the users. We started working with them. Today, we already have an implementation. This is a picture from yesterday at ROSCON. Yeah? They showcased the RMW layer for Zenoh in ROS2 yesterday. The repository is already available in the open source. Please feel free to have a look at it. The release has not yet happened, so the next milestone for us to get the release for the RMW Zenoh. And the next year, it will be the tier 1 middleware for the ROS2. Yeah? It's planned for the next year, 2025. So that's on the left. We have the intrinsic colleagues from the robotics, Open Robotics. On the right, we have Julian Enoch from Zetta Scale. So we have such great protocol, and people start using it, customers start deploying it, and they need some kind of mechanism to able to make their life easier, like to configure, to deploy, to maintain, to monitor. And that's where, ladies and gentlemen, we have created a platform called Zetta Platform. And many talked about how we can leverage on open source, and what are the business models we can have. So this is one of our business models, which we created on top of our open source platform, which we kept outside. Yeah? The Zetta Platform mainly helps you to configure your Zenoh infrastructure, your private infrastructure. Also, you can have the infrastructure deployed in the cloud and have them configure and connect them, and also helps you configure some of the configurations what Zenoh has, like distributed storages. You can configure access control and so on and so forth smoothly using our platform, and monitor everything from a single place. So if you compare the mainstream protocols and mainstream platforms out there, Zenoh checks most of the abilities. It can scale from microcontroller to the cloud. Thanks to its protocol efficiency, it has less overhead. It does the batching out of the box. For some IP, you have to have a special feature to do the batching for you, and this is something you have to buy, possibly. But for Zenoh, it's free. It's out of the box. So thanks to the protocol efficiency, it is energy efficient, and we have a platform, as I'm going to explain soon. And it's high performant. It can work on the cloud. It can work on the net. So it basically checks all the marks and and stands out as a unique protocol out in the market. So to deploy your Zenoh infrastructure, you started building applications, and applications are spanning across the cloud, edge, and your on-premises. There are multiple premises. Things get really out of the place. So you have to provision the routers in the cloud. You have to provision the on-premise routers to connect your applications to the cloud. And you have to configure the connections between the routers. You have to configure the access control mechanisms. And you may want to connect to the MQTT or DDS or other legacy applications. Then you can use the plugin. You have to configure the plugins. You have to also make sure that storages are placed in the right location. So you have to also do the configuration of that. And you also have to take care of the security aspect, where you have to generate the certificates and keys for authentication, encryption, and so on and so forth. And you have to monitor the entire status of your system. Yeah? What's going on in the Zenoh infrastructure, where if there's a router failing, or if there's an application that has been, if something has not published, what happened, and so on and so forth. So this has to be done by yourself. This is where our platform helps you. Basically, with few clicks, like sipping a coffee, you can deploy a Zenoh router in the cloud. You can select the region of your choice, and also you can also generate the configuration for the on-premise router that you want to connect to the cloud. And you can, of course, generate the certificates and keys, so you can just by doing a simple click, download the certificates and load it on your applications or routers. Zenoh on-premise routers, have them connect to the router in the cloud. And you can also monitor what are the routers in the system, how are the connections. You can, for the redundancy, you would want a single router connected to multiple routers, so if something falls down, it takes a different path. And you can also monitor what are the applications in the systems, and so on and so forth. Yeah, this is you can see the live data from the system, or you can see the cumulative data, what's happening in the network. And you can see the entities within the Zenoh, what are the subscribers in my system, how many queryable are in the system. And you can also integrate with DDS-based systems. So we have a bridge to DDS, where you can monitor the DDS traffic, DDS participant, entities, readers, and writers. So somewhere across the world, you can be sitting with your laptop, just getting into your robot or your car somewhere sitting over there. You can monitor what's happening inside, for instance. And also we have integration with ROS. So this is an overview of a ROS graph when you want to look into the robot. So all of these capabilities makes your life easier to manage the Zenoh infrastructure, have other plugins connected to the Zenoh infrastructure, and have them monitor from a remote location. Or we also have this tool as a offline tool, so you can also use it on the on-premise to monitor some of the key parameters in the system. So we did a demo with some of our colleagues. We used 2 bikes and 2 cars with a tracker on it and tracking the live location. And basically, when they're getting closer to each other, it sends an alert. The application, which is located in our headquarters, basically creates an alert. Yeah, they're coming close to each other. So it's kind of a V2X example or a fleet management example, what we tried to demo it in a small video. So please take a look at it. Oops, sorry. It has some music. I don't know if you can play music. No? Okay. Let me try it. Oh, perfect. Thank you. No? Okay. That's okay, I can explain. That's okay. Yeah. So my colleagues here basically driving the motorbikes soon. That's my CEO, CTO, Angelo Cosciaro on the right side, and we have Gabriella on the left side. Yeah, so there you go. They'll start driving the motorbikes and also a couple of cars, and you will see the live tracking, which is being tracked at our headquarters. And whenever they come close to each other, there's an alert which has been raised, and just a small demo that we can show the V2X capabilities with Zenoh using the Zetta platform. So they're just driving out of from our office. And there's also some information, yeah, and they go a couple of cross lights, yeah. So whenever they come closer to each other, you will see, yeah, they're too close to each other. Kind of a simulation of V2X scenario. Yeah. That's the architecture. So kind of, it works pretty smoothly. We didn't have to do any changes. It just works out of the box. That's my project lead working on the car, driving the car, doing the live tracking. Yeah, just one protocol from your device up to the cloud and using all the mechanisms, what it provides on top of that. So that's, ladies and gentlemen, Zenoh. And we just needed less than a year to build this platform using Zenoh with very few resources. So most of the times we talk about the Chinese speed and American speed, but this is what I can give a positive example of European speed and efficiency. We are not alone. There are other companies like Ferrosystems and Isorix, Excite, and also OxidOS guys doing a great job. So we need your support to take this to the next level. With that, I want to show a couple of European projects that we are working in the automotive space. So eco-mobility and HI trust. With that, thank you everyone for your attention. Questions?
Thanks, Vani. Questions? Rex?
First of all, thank you for the presentation. I have a question. So Stephen and Kai, they talked about a business model. So can you say a few words? What is the business model behind ZettaScale then? You provide so much, but yes. How do you earn money?
It's exactly what the platform is, one of the business models what we have, and we have a derivative of Zenoh for something we are certifying for the safety of automotive from the ASLD context, ASLD, ASLB, and so on and so forth. And also this is something we can use in the aerospace industry as well. There's a traction in aerospace where they're asking for Zenoh in this field as well. So certification and the platform are the two business models what we have on top.
Hi. I would have one question in this brokered setup. So in the cloud, do you have any kind of replication, message replication you can configure? So yes. To avoid the case of a broker going down and the message being lost, or so other message loss protection?
There is a deduplication feature which enables you to remove the duplicate messages that are received multiple times.
And not deduplication, but replication. So normally you would store a message coming in on maybe 2 hosts or 3, so that the host which receives the message, if it goes down, that the message isn't lost.
And then it is received by other hosts, isn't it? No.
Yeah, normally a client publishes a message, goes to the host, and the host directly goes down while publishing the message. In some systems, like the MQTT broker, they have a replication factor you can configure. So a publish and you get the ACK back, then it's on 2 hosts. So if one goes down, the message isn't lost. Do you have some similar features?
So we have something like, there is a storage mechanism, or where you can have mechanism where some other Zen application holding the data for you, that so that can perhaps provide the information for the lost one when it comes back. This could be something applied in a similar context for Zenoh. Someone else is holding the data rather than the publisher, so when the respective host comes back, and the other one who is holding the data for you can give the information that has been lost while it was sent. So that kind of configuration can be applied.
Oh, okay, thanks.
Further questions?
First, of course, thanks a lot for the interesting presentation. I noticed that you listed AutoZAR Classic for automotive targets. Do you also think of adaptive AutoZAR as also one of the automotive targets?
So mapping to AutoZAR adaptive is quite straightforward. The APIs gel really well with the workings of Zenoh. So most of the time, we don't need a special implementation if you can directly apply the methods to the AutoZAR API quite easily. The Zenoh API maps very well to the adaptive, so people are just using it and applying it into the adaptive framework.
Thanks.
The next.
Firstly, thank you for your presentation. My question is about that table that you showed, in which there were the features which ROS needed on the side, and there were the ones that we were all green in Zenoh in that picture, except for one, which was access control security.
Yeah.
And the question is, do you plan on, in a way or another, integrating that? And,
it's already done. The picture is 2 years old.
Okay.
So it's not, I mean, we took the screenshot from their evaluation 2 years ago, but it was required even for our platform, because if some application sends the data, it should not cross the on-premise. Only selected data has to get out of for your local network, and this is where you can use the access control mechanism to fine-tune what has to be sent out, what has to be subscribed to, and so on and so forth.
Because, for instance, one of the things that comes to my mind when I think about Zenoh is, for instance, queryable. If we have an IoT device which queries for some data, we don't know by definition where that data will come from, but it could come from anywhere in the Zenoh network. Is there a way to limit that?
Yes, it is. Yeah, that's exactly the access control. What we have implemented addresses this problem.
Perfect.
Further questions?
Thanks, Hani, for the presentation. Just have one question concerning the deployment in microcontroller. So which hardware target did you use for this?
For the microcontroller?
Yes.
You can use all the famous microcontrollers out there. We have customers using in a microcontroller which has memory as low as 512 kilobytes. So it takes even less space, 20% of or 10% of what the entire memory is available. But we have deployed in several microcontrollers, STMs and NXPs and all the major microcontrollers what are out there.
Okay, so it's released for different platforms.
You can, yeah. We have already support for several platforms.
Yeah.
But if you think there is another platform we should support, it's not a major work for us.
Okay, and the pilot testing you did, so which platform you took for this?
I have to look, but if you go to the Zenoh Pico GitHub page, we have the list of platforms, what we tried and tested today, but it doesn't stop us to support any other new platform. Yeah.
What's about the Infineon microcontrollers?
Yes, the customer already using it in Infineon, actually.
Okay.
Yes, I have a couple of weeks ago spoken to the colleague.
Yes, for sure.
Yes.
Thanks very much for the presentation.
Most welcome.
Further questions? It Doesn't seem so. So once again, thank you very much, Fani.
Yep.
Big applause.
Thank you.
Not to forget, we have in November our SDV hackathon, so please feel free to register, come to us, and bringing SDV technologies forward. Have a look into it. You have the flyers over there, so please join. And now we are ready for lunch and continue here at 1:30. So enjoy your lunch and have a great break and a great day. Thank you.